Hi guys, am I audible and visible? Alright, yes, I guess I'm audible and visible. So as I always say, Namaskara everyone, Andariki Namaskaram, Ellargu Swagatam, and a very warm Vanakkam to Vedantu J English channel. This is me, your master teacher Nabamita Ma'am, and today we are here to complete this chapter called as Atomic Structure. So what's up and how are you all? I hope that you all are doing great and I have majorly, I have basically written everything here so that, we do not consume much time while we are, writing it down. So everything will be here in the slides only. Okay. Now, this is the atomic structure syllabus. Everybody, once again, letting you know that J first attempt and J second attempt, it is the same syllabus, absolutely same. There is no difference whatsoever. But in this syllabus, you can see that, your topics related to Thomson's model or Rutherford's model, those are no longer there in the JEE syllabus. Obviously, it does not have much work because Thomson's and Rutherford you already have studied in your younger classes, right? So it directly starts from the nature of electromagnetic radiation. It starts with photoelectric effects, spectrum of the hydrogen atom, Bohr's model, and all of these. It directly starts from there. Okay, everybody? Yes, guys. So very good evening, everyone. Yes, very good evening. Hi, Akshaya. Hi, Aishwarya. Hi, Vinay Kumar. Hello, Pushpa. Hi, Sumati. Very good evening, guys. Quickly go and call up your friends as well so that we can start with the session and nobody is missing out on anything. Notes you are not uploading. Who said that, Bacha? I actually am sending it to the channel manager. Is it not getting uploaded? You know what? After this session, I will definitely I will definitely check it out that why is the notes not getting uploaded. And I'll find it out. Okay? I'll find it out and I'll definitely talk to him. Okay? Alright, so shall we start, guys? Are you all ready, everybody? Are you all ready? Hey, hi. But I do not feel like taking your name. Why is your name Waste Fellow? Why? Why are you a Waste Fellow? You're not a Waste Fellow. You're the best fellow. Hi, Bachus. Hi. So, chalo, let us start. Yes, everybody is ready. Please have a pen and a paper. Yes, please have a pen and a paper so that whatever you do not know, you can quickly write it down and that way it will be a good revision. You will also be engraving. You will also be basically, things will get engraved in your mind. So, please do that. Okay? So chalo guys, let us start with the first thing, everybody. Now atomic structure. So guys, this atomic structure, the story of atom, it started long back, isn't it? Somewhere around 400 before Christ. Yes, the year was 400 years before Christ, right? There were Greek philosophers who thought that, there has to be some fundamental building blocks of matter and all of these. And the word atom came into picture. Atom means that it is uncuttable. That means you cannot cut it down or it is non-divisible, right? All of that came into the picture and then atomic theory started to come into picture. So when we talk about atomic theory, right, we have a lot of things like we have Dalton's atomic theory, we have Rutherford's atomic theory, we have Thomson's model of atom and all of these, but those were very easy peasy sort of, atomic theories and we don't really talk about them anymore with respect to our J syllabus, right? Now, in your NCERT, you must have also seen that there was discovery of subatomic particles such as, discovery of electrons, discovery of protons and all of that. For that, I have a chart that I will just show you. But once again, you do not have to go through it at all. Okay? Nobody is going to ask you questions related to who discovered what. It's not a general knowledge question. It's not a general knowledge quiz that you are playing. It's a J, right? It is basically the matter of your future, everybody. Okay? Alright, so after all of these, there is a point of time when we come across isotopes, we come across isobars and all of these, right? So let's talk about that, everybody. And first thing first, please note down here, please note it down here that how do you denote an element, okay? How do you denote an element? So if you check it out, this X is the symbol of the element that you are going to write, okay? This X is the symbol of element. For example, if you want to write it for helium, you will write here He. Okay. Now mass number. What is helium's mass number, guys? The helium's mass number is 4 here. And what is helium's atomic number? Atomic number of helium, my dear student, is just 2. Okay. What is it? It is just 2. Right. So this is how basically you denote an element. Now again, this is very basic that I'm starting from. So I hope that you are going to stick with me till the end of the session. The session will be ending at around 6 o'clock. So it will basically be about 2 hours, not more than that. Within 2 hours, I'll be trying to complete each and everything that you need to understand before you sit for the JEE, everybody. So I'm starting from the basic. I hope that you will be able to understand everything. Okay? Alright. Now guys, if you look at it, you need to understand certain bits and pieces of this, not just this, representation, but you also have to understand what is atomic number. What is atomic number? Atomic number is basically equal to number of protons, because number of protons will not change in an atom. But in a neutral atom, if you have a neutral atom, that means the atom does not have any charge. At that point of time, you will also notice that atomic number is equal to number of electrons in a neutral atom, by the way, my dear bachus. Okay, neutral atom, once again telling you. So atomic number is equal to number of protons, or it is equal to number of electrons in a neutral atom. And do you notice here that it is denoted by Z? Okay, it is denoted by capital Z. Do not write it as capital A. Capital A is for mass number. Okay. Mass number is denoted by capital A, and mass number is basically number of protons plus number of neutrons that are present in a nucleus of the atom. Because you know that what is neutron? A neutron and a proton together, they are called as nucleons, isn't it? Yes. So in the nucleus, the proton and the neutrons together will be your mass number, because both of them contribute towards the mass number. Electrons have negligible mass, right, everybody? Yes. Next is isobars, everybody. Isobars have different atomic number, but they have the same mass number. Everybody please note it down. Same mass number, different atomic number, that is your isobar. What are isotopes? Isotopes have identical atomic number, but they also have different mass number, and the difference in the mass is because of difference in number of neutrons. Okay, difference in number of neutrons, everybody. Okay. And what is isotones? Isotones have same number of neutrons, everybody. Okay. Isotones have same number of neutrons, everybody. Am I clear, guys? Is this understood, everybody? Any doubt? Perhaps till here nobody has no doubt. Does anybody have any doubt? Yes. Till here everybody has understood everything, I'm hoping. Yes. Okay, by the way, everybody, one more correction here. Isobars, what do they have? They are of different chemical elements. Okay, the different chemical elements. Yes, yes, same mass number, but different atomic number, right? So one more thing, everybody, understand that they have same number of nucleons, same mass number. That means same number of nucleons. You want an example of isobars? Let me tell you, everybody. Sulfur, yes, then you have 40 chlorine, yes, then you have 40 argon. These are all isobars. Okay, these are all isobars. Okay, everybody? Yes. Say examples. Vinay Kumar, I've just given you examples of isobars. Isotopes and isotones, I'm hoping that you know it, because isotones and isotopes, you have learnt about it in your early childhood days, everybody. Okay, guys? Yes, shall we move on from here? Let us move on from here. Acha. So representation of an atom, once again, please just check it out. Yes, do not forget it. So you have your element symbol, then you have A is your mass number, Z is your atomic number. Okay. Now here, guys, as I was telling you, so this is the chart that I was telling you about, and in this chart, everybody, you will be able to see that who discovered what, everyone. Electrons were discovered through the cathode ray experiment, and it was discovered by J.J. Thomson. The relative charge was -1, and mass for electron is 0. We know that electron does not contribute towards the mass at all. Hence, mass of electron is written as 0. Then we come across proton. Protons were discovered through the canal rays or the anode rays experiment. It was done by E. Goldstein, and here we see that the relative charge is +1 and mass of proton is only 1. Okay, mass of proton is only 1. Then we come across, everybody, neutrons. And if you know neutrons, does anybody know who discovered neutrons? Does anybody know who discovered neutrons, guys? Anybody who can tell me? Who can tell me who discovered neutrons? Anybody, guys? Anybody? Come on, come on, come on. Somebody tell me who discovered neutron. Somebody? Anybody? Nobody? No one? Come on, guys. I really hope that you know. Come on. Quick. Nah. Hey. Neutrons were not discovered by Goldstein. Neutrons were discovered by Chadwick. Okay. It was discovered by James Chadwick. Okay. James Chadwick was the one who discovered neutrons, and here is your neutrons. And do you know what was the experiment? The experiment was that he took some beryllium. Okay, he took some he took some, yes, what did he do was bombardment of alpha particle on on beryllium nucleus. Okay, so what he did was he took beryllium nucleus, and on that alpha particles were bombarded, and that's how he figured out that there is also neutron. Now neutrons do not have any relative charge, hence it is 0, and the mass here will be 1, my dear students. Okay, and once again, everybody, all the other terms I have written here, see, check it out, everybody. Isotopes. What are isotopes? Isotopes have same atomic number, different mass number. Then you also have isobars, isotones, isoelectronic species. You have isodiaphers, and you also have isosteres. Okay, you have isosteres, and all of these, the definitions are written here, everybody. Just go through the definition, everyone, if you want. Just go through the definition, everybody. What are isobars? Isobars, the same mass number, different atomic number. What are isotones? Same number of neutrons. What are isoelectronic species? Same number of electrons. What are isodiaphers? Same numbers, same difference between neutrons and protons. That means you have number of neutrons, you have number of protons. If you subtract the number of protons from number of neutrons, the number that you will be getting, that will be similar for different elements, and that is your isodiaphers. Finally, you have isosteres, same number of electrons and structure, that is called as isosteres. All right, everybody. Yes. Yes, everybody. Do not need it, guys. Do not need it. Everybody, focus on what I'm teaching you. Okay, focus on what I'm teaching you. Can you explain unit mass of an atom? For unit mass of an atom, guys, if I go through that, then we will once again have to get into the discovery and all of these, right? We do not need that. It is not there in your syllabus. Go through the syllabus once again. The syllabus also is written here, everybody. Check it out. See, the syllabus is also right here. Okay, so we are now directly going to start from electromagnetic waves, everybody. So the basic part of it is done, everyone. Yes, the basic part of it is done. Now let us quickly go to electromagnetic radiation. So first of all, everybody, we all know that what happens is classification of waves, right? You all know that waves can be divided into two categories. One is mechanical waves and the other one is non-mechanical waves. These mechanical waves, everybody, what is written here, that means that they need medium to travel. What do they need? They need medium to travel. That means, everybody, do you remember in your class 8th standard, 9th standard, you have read about sound waves? Sound waves are mechanical waves. Sound cannot travel in vacuum. Do you remember, everybody? Sound cannot travel through vacuum. Do you remember, everybody? So sound waves are mechanical waves, isn't it? But there are also non-mechanical waves. That means that they do not need any medium, and they, my dear students, are sometimes called as electromagnetic waves. Bole to example, if you want, light. Light is also wave, isn't it? So light is a non-mechanical wave. It does not need any medium, everybody. Don't you remember this, guys? From sun to earth, there exists vacuum in between, yet the light takes 8 minutes and it reaches your earth. So yes, that is non-mechanical wave. Now let us understand what is this electromagnetic radiation, right? We would like to understand what is electromagnetic radiation, isn't it? So suppose you have an electrically charged particle. When I say electrically charged particle, everybody, what is it that comes in your mind? Does electron come in your mind? Because electrons are electrically charged particle. Am I right, everybody? Yes, absolutely. So when you have an electrically charged particle, suppose you have an electron, right? Or it can be something else also. So when you have an electrically charged particle which moves under acceleration, that means it's accelerating, right? Just kidding, everybody. Acceleration, you understand, right? Yes. So acceleration, it is moving under acceleration, everybody. Yes. Okay. And then what happens is alternating electrical and magnetic fields are produced and they are transmitted. Transmitted bole to they are transmitting. Transmitting is like, going from one place to another. So they are produced and they are transmitted, and these fields are transmitted in the form of waves, and that wave, my dear student, is called as your electromagnetic radiation. So everybody check it out, guys. Imagine, so everybody, yes, look at this, everyone, look at this, guys, look at this. Yes. So suppose I have this, right? I have this, yes. So what am I going to do is, this is my charged particle, and what if I just, if I just like, acceleration, and I'm moving it. The moment I move it, it will give out some amount of waves. The waves will be produced and the waves will be transmitted, and those waves are your electromagnetic radiation. Yes, all right, everybody. So whatever is emitted, that radiation is a wave. I hope I have explained it, Mahesh. Yes. What did I say? I said that the radiation that is coming out, that radiation will be coming out in the form of waves. So electromagnetic wave, electromagnetic radiation, one and the same. Those both of them are interchangeable and you can use it. Okay. Now, my dear student, we come across something that is called as Maxwell's electromagnetic wave theory. So what did Maxwell say? Maxwell tried to explain the interaction between the charged bodies and the behavior of the electric and the magnetic field. And you know what he found out? He found out that these fields, they are transmitted in the form of waves, which is called as electromagnetic waves. And look at this, everybody, okay? So the waves, they are perpendicular to each other, everybody. Do you notice this? The red color ones are like this. Yes, the red color ones are like this, and the green color ones are like this, everybody. The red are like this and the green are like this. So they are perpendicular to each other. What are they? They are perpendicular to each other, everybody. Do you notice? Do you notice, guys? Yes, everybody. Yes. Yes. So do you see this? Yes. So these are, these are perpendicular to each other. All right. These are perpendicular to each other. I hope that this is clear to you all. Is this clear to you all, guys? Yes. Yes. Yes, everybody. Okay. Now, what we need to understand is the characteristic of the electromagnetic radiation. What are the characteristics? Characteristics bole to some properties that they exhibit, okay? Some properties that they show, and those properties, number one, everybody, is wavelength, everyone. So what is a wavelength, everybody? Just come here, everybody. Just come to this picture, all right? Can you notice this picture, everybody? Yes. So right here, everyone, from this wave to this wave, yes, this distance, this is called as your wavelength. What is this called as? This is called as your wavelength, everybody. And how is it measured? It can be measured in meter, it can be measured in nanometer, it can be measured in what? In angstrom, okay? It is measured in angstrom. It can be meter, nanometer, angstrom, or whatever unit you would like to use, okay? Then we come across frequency. What is frequency? My bachus, everybody, tell me something, bachus. Frequency you have known to exist from a very long time, isn't it? Yes. Frequency has come across. Frequency, you came across frequency from a very young age, isn't it? What is frequency? Number of oscillations per second. Exactly. So here, instead of oscillation, because we are talking about a wave, what can we say? We can say that number of waves passing through a point, yes, passing through a point in space in a unit time, okay, that will be your frequency. What is the unit of frequency that you use? You use s to the power -1, or you use hertz, that is Hz, okay? Basically, if you want to say, it is cycles per second. That, my dear student, is your frequency. Easy peasy biryani tasty till now. Then we would also like to measure the speed or the velocity of the electromagnetic radiation. The speed of the electromagnetic radiation. What is it, everybody? You all know it. C is equal to 3 into 10 to the power 8 meter per second. Yes, that is the speed of light or velocity of light. You know, we all know that speed is a scalar quantity, and as you grow up, as you come to this 11th and 12th standards and whatever, right, we do not talk about the scalar quantities so much. We mostly take everything into consideration in the vector quantity. So speed is in scalar quantity, velocity is in vector quantity, and here once again we would like to consider velocity a lot more than speed, everyone. Yes, no doubt about it that there will be certain questions where maybe they have written speed, and there will be certain questions maybe where they have written velocity. However, we all know that when we are talking about electromagnetic waves, we are basically tending or inclined towards velocity, right? So here in this case, doesn't matter what they are using, we all know that it is going to be a vector quantity and it is going to be velocity, right? Makes sense. Now, then we come across something that is called as wave number, everybody. Now, what is wave number? Wave number is number of waves per unit length. So, if you take a unit length, right? If you take a unit length, in that unit length, how many waves are there? That will be your wave number. And what is this? This is basically the reciprocal of wavelength, okay? So if this is wavelength, how do you consider wavelength? Wavelength is your lambda, isn't it? Somebody had also written it down. Wavelength is lambda. That means that wave number, everyone, but choose writing it down here, guys. Okay, what is wave number? Wave number is reciprocal, that means just the ulta, so it is 1 divided by lambda. And please note it down, because this is going to be very important as and when we go forward. The moment we get into the picture of Rydberg's constant and you know, the Rydberg's formula, there also we would like to introduce certain terms like wave number. Last but not the least, everybody, is your amplitude. What is amplitude, my dear student? Amplitude is basically the either height of the wave or the crest of the wave. That means that, let me show you here, everyone. Amplitude is either this from the wave, okay, this black line that you see, it is either that, or it is either this. So either it is the height from the rest position or the crest from the rest position. It can also be for the green. For the green wave also you can find out the amplitude like this, or it can also be like this. Okay, so these black marks that I have mentioned here, these are your amplitude, everybody. Are we clear, guys? Till here is everything clear? Till here is everything clear, guys? Is it all clear? Yes. Then we come across the electromagnetic spectrum. Okay, spectrum, it's not spectrum, it's spectrum, sorry. Then we come across electromagnetic spectrum. In the electromagnetic spectrum, you have spectrum. What do you mean by spectrum, guys? Spectrum means that from, you know, starting from one extreme to the last extreme, okay, whatever falls in between, that is called as spectrum, right? For example, that rainbow color that you see, it has all the 7 colors, so that's a spectrum. Spectrum is starting from one extreme to the last extreme. That will be called as your spectrum, everybody. Yes, now in this spectrum, my dear bachos, you have cosmic rays, gamma rays, X-rays, UV rays, visible rays, infrared, microwave, radio wave, everything. So now your question will be, ma'am, how do we remember this? How do you remember so many of these, you know, so many of these rays? Okay. So here is my trick. My trick is, everybody, that can't find. Okay. Yes. What can you say? You can say that. What was it? Can't find. No. Can't get XUV in my range. Yes. And this is the truth, my dear student. It is the truth, everybody. You know why it is the truth? Because XUV cars, they're very expensive, right? And right now I'm not able to afford it. Right now I'm not able to afford an XUV car. So this makes sense, everybody. Can you guys? Can you, everyone? Can you afford the XUV car on your own? No, without your parents' help, by the way. Without your parents' help, everybody. So yeah, I think this makes sense to me. That's how I remember. Can't find XUV in my car. CANT, can't, so that means it is cosmic rays. Get means gamma rays. XUV is your X-rays UV and visible. UV is your UV and V is your visible. In my range is infrared, microwave and your radio wave, everybody. Got it, guys? Yes. So one thing that you have to remember, as you go from left to right, okay, as you go from left to right, everybody, as you go from left to right, do you know what happens? Do you know what happens, everybody? You will notice that the nu, okay, that means the frequency decreases, everybody, but the lambda increases. As you go from left to right, you need to know that frequency decreases, lambda increases. That is, your wavelength increases but frequency decreases, everybody. Okay, and here is a formula for you which is very, very, very important, everybody. This is called as the interconversion formula, where you get to see that C is equal to nu lambda. C is your velocity is equal to frequency multiplied with wavelength, that is lambda, everyone. Yes, guys, am I clear, everybody? So that means that from this formula you can also note it down that nu is equal to 1 by lambda, and if it is 1 by lambda, my dear students, what can we say? We can say that nu is equal to your wave number. This is your wave number, 1 by lambda, wave number, everybody. Is this clear, guys? Is this clear? So basically what we're trying to understand is that we are here to tell you that EM radiation, that is electromagnetic radiation, they have a, but they also have a particle nature. They also have a particle nature, and this was the time when we understood that, you know, these guys, they have both the nature. They have dual nature. They have particle nature as well as the wave nature. And this was the time when we understood that the smallest packet of energy possible will be called as photon or quanta. Isn't it? Yes, photon it's for visible light, and quantum or quanta it's for the other radiation. Okay, so what is the energy of the quantum or the photon? It is equal to h nu, which is equal to hc by lambda. How did we figure it out? See, if it is h nu, right, if it is h nu, that means that from the formula C is equal to nu lambda, all you are doing is you are adding an h here, you are adding an h here. That means that you can definitely write it as hc by lambda. Am I making sense, everybody? Yes, does this make sense? So what is going to be the total energy of radiation? Nothing much. All you have to do is you have to add another term here, that is n. What will be n, everybody? nh nu, which is equal to nhc divided by lambda, everyone. So till here, everybody, is everything clear? Till here, is everything clear? What is going on in this thing? Mahesh Bacha, please understand that what I am telling you now, please understand what I am telling you is actually absolutely apt with your do. What do I do? So I'm not able to understand, Bacha. I'm not able to understand. What do you want me to do? You tell me. If I take you through it, then you tell me no, don't take us through it. If I don't take you through it, then you are telling me that you have to do this, you have to do this. And yes, Bacha, Mahesh, even in your NCRT, this is there. No one is going to ask you about the derivation. Derivation will not be asked in your JEE Mains. Derivation will be asked or would have been asked in your board examination, or maybe you need to know according to the JEE Advanced. Okay? Right now you do not need it. So please study what I am teaching you. Okay? Please study what I am teaching you. Is there any doubt otherwise, everybody? Any other doubt, guys? Any other doubt whatsoever? The formula is this only. Salt analysis and purification. Will do, Jeff. We have it in the plan already. We have it in the plan. We have it already. Don't worry about it. Yes. Okay? Interconversion formula. This is the interconversion formula. You can go and check any other channels also if you want. But nobody would have taken you through this derivation. Okay? This is it. C is equal to nu multiplied with lambda. But what was your question? What was your question? What were you asking? Okay, acha, elaborate. Just this. Just this. Okay. Okay, Mahesh, what you asked me was actually very common sense. Okay, but let's check it out, bacha. Let's check it out what you're trying to tell me. Okay. What you are asking me is, you are asking me, bacha, See, what you are asking me is, let me write it down. See, C is equal to nu lambda, right? Now, if I write nu this side, nu is equal to what? C by lambda, right? Right, everybody? C by lambda. That means that nu is equal to 1 by lambda. Can I write? Can I write it like this? That's it. That's it. And what is 1 by lambda? 1 by lambda is reciprocal of the wavelength, isn't it? So what is that? Wave number. That's it. That's it. That's it you are asking me to derive. This is so simple, bacha. So simple. All you had to do was cross multiply. Okay. Nobody has any other doubt, right? Nobody has any other doubt. Shall we move on, guys? Still electromagnetic radiation. I hope that everything is clear with you all. Acha. Now what happens, we need to understand, everybody, we need to understand one thing, that what really happened was, okay, what really happened was the failure of classical physics. So we come across something, just after this, we will come across something that is called as black body radiation. And this classical physics, till now we have not entered quantum physics, by the way, guys. We have not entered quantum physics. So everybody check it out, that the classical physics could not explain the emission radiation from a hot body. That is, your black body radiation could not be explained. We will also, in a while, we will also be learning about photoelectric effect, and that was also not explained by classical physics. Variation of heat capacity of solids as a function of temperature. You must have noticed, right? What happens as you heat something, especially iron. If you take iron, okay? If you take iron, and what happens if you heat it? Initially, it starts to glow red hot, and as you keep heating it, at certain point, the color changes. That was also not explained by classical physics. And apart from that, obviously, the line spectrum of hydrogen could not be explained by classical physics. That means that we needed a different kind of physics. And what was that different kind of physics, everybody? As we all know, the very interesting, the major love of each one of our lives is what? Each one of our lives, it is your quantum mechanics. So yes, we are about to study quantum mechanics, guys. But before we study quantum mechanics, tell me something. In your physics chapters, have you read about something that is called as diffraction and interference? Have you read about something that is called as diffraction and interference, everybody? Now, did you know that this diffraction and interference, it could not be explained, or it could not be exhibited by the particles? It was only showed by waves. Yes, the diffraction and interference can only be showed by waves, everybody. And what is diffraction? Diffraction is basically when the waves, they bend, right? And the waves, they do bend. Absolutely, they do bend, isn't it? The waves, they do bend. What is interference? The interference can be of two types. Interference can be destructive interference, where the waves are out of phase. Yes, where the waves are out of phase, that means they will nullify each other, right? They will nullify each other. And you also have constructive interference. In constructive interference, what do you have? In constructive interference, there will be addition of the waves, and there is a chance that it might turn out to be bigger than the initial waves that you have taken, isn't it? That is the whole difference between destructive and constructive interference. Am I right? And what is diffraction? Diffraction is bending of waves. So all of these together, yes. Prana, thank you so much, BK Saranya. After 30 years of age, yes, please go ahead and teach me some English pronunciation. Yes, please go ahead. She's correcting me there. Seriously, you guys? Huh? Is this how you're going to clear your IIT JEE? Huh? Seriously? So much of distraction you have? Bro, really? I mean, how much can you distract your teachers here? It is diffraction. What did I say? I have been telling you diffraction and interference, diffraction and interference. What did I say? बड़े आए चले मेरे को correct करने के लिए यहाँ पे. Correct where I am wrong, I do not mind. But don't do it like obsessively, don't do it. Okay? Anyway, so this we have understood. Now that we have understood this, now we are going to try and understand what is black body radiation, everybody. So basically what happens is, no worries, it's okay. When you heat solids, yes, when you heat solids, they emit certain radiation, okay? They emit certain radiation, and these radiations are for a wide range of wavelength, okay? Alright, yes? Alright, what am I saying, everybody? I am saying, everyone, once again, please listen to me, please listen, pay attention, everybody. If you want to understand black body radiation, this is important. This is the beginning of black body radiation. When you heat a certain solid, it can be iron, it can be copper, it can be anything else, right? When you heat a certain solid, they emit radiation. What is radiation? Do you remember? Electromagnetic radiation. They are charged bodies. So charged body, when you make them move through acceleration, they emit some waves. And here also, somewhat similar. When you heat a solid, they emit certain radiation, and that radiation is over a wide range of wavelength, everybody. Okay, see, this is exactly what I was telling you. So when you heat an iron, what happens is initially it is dull red, yes, and then progressively as you keep heating it more and more, what happens? As you keep heating it more and more, it starts getting converted to more red. It starts to glow red as the temperature increases. Am I right, everybody? And then when you have heated it so much so that the radiation now emitted is becoming white in color. Yes, everybody. Yes. When you heat an iron rod, initially it is dull red. From dull red, it gets converted to glowing red. After glowing red, as you keep heating it, it becomes white in color, everyone. Yes. And then after some time, it becomes blue in color as the temperature goes very high. Okay. So this is just about iron. I'm giving you an example. Okay. But what happens is, everybody, the ideal body, ideal does not exist. Ideal, supposed to exist, ideal body, yes, which can emit and absorb radiation of all these frequencies, that is called as your black body radiation. Just like the black hole, guys. What happens in the black hole? In the black hole, the light does not escape. The gravity is way too strong, isn't it? Yes. So what is it doing? The black hole is basically, at certain point there was also light in it, but it has not allowed to escape anything and everything. The similar way, this black body, it is emitting and absorbing, emitting and absorbing, emitting and absorbing the radiation of all frequency, and that is called as your black body radiation, which is emitted by a body. If it is emitted by any kind of body, then that body will be called, such a body will be called as black body. Got it, everybody? Is this clear? Is this clear, everyone? Yes. Is this clear, guys? What is black body radiation and what is a black body? Yes. Do we understand? Do we understand, everybody? This is clear? Is this clear? Is this clear? Yes? Yes, is this clear? Great. Okay. Perhaps no doubt regarding black body. Is everybody clear with black body, guys? What is black body? Do we understand? Even showed you the example now. Yes, everybody, are we all clear with it? Okay, great. Now, guys, let us come across something that is called as Planck's quantum theory. Okay. Let us understand something that is called as Planck's quantum theory. It is very important to understand Planck's quantum theory. Only then we will be able to understand photoelectric effect even better. Okay? Alright, yes. That I don't know, Sanjay. If there is a question, it will come. If there is no question, it will not come. It will come at the end. Okay? I don't know. We will see. However, I would like to take it. Okay? So, Planck's quantum theory mein, what Planck did was, Planck suggested that, see, Planck suggested that atoms and molecules, they emit energy. They could emit energy. But when they're emitting energy, they will only emit it in discrete quantities and not in continuous manner. Acha, guys, to understand this better, you know what? I have an example, everybody. Okay. Have you seen the chips packet, the Lay's chips packet, the 5 rupees chips packet? Yes. That is the smallest packet that you get in the market, isn't it? Yes. That is the smallest packet in the market that you get. Correct? Correct, everybody? Yes? Do we or do we not? Do we or do we not? We get those packets, right? Yes, the Lay's packet, the 5 rupees packet. So imagine, so that single packet, it is not continuous, right? It's a small packet. Actually, it's a small packet. But you see, when those small packets are joined, those small packets, when they're joined by a simple line, it looks like a line of blue. The blue color lace packet, everybody. The blue color lace packet, everybody. ये देखो, बीके सारण्या, बच्चा पढ़ना है कि नहीं पढ़ना है आपको? कि आपको मेरे साथ आर्ग्यू करना है? हाँ? I am talking about the 5 rupees. She is coming and telling me in some villages rupees 2 is also available. What do I do, bacha? Should I give you example or not give you example? I'll just send you the PDF. I think you can read it because it feels like you know everything. I'll give you the PDF. You can read everything. I am the movie director. Let me direct the movie. Listen. With a popcorn in your hand, listen and write what you don't know. Okay? Don't distract the class like this. Abhi virtual pitti milega. Okay? Anyway. Okay, so as I was telling you, now see, when you look at it from the far, although in your mind you do know that it is just a packet, but when you look at it from a very far away, it looks like a blue color line, isn't it? Yes? Blue color line, isn't it? But what is that line made up of? That line is made up of those small packet, and that packet is your quanta or quantum. Getting my point, everybody? That packet, my dear student, is your quanta or quantum. The smallest packet of energy, the smallest packet of lace, smallest packet of energy will be called as your quanta. Getting it? Getting it, everybody? Now, Planck said that he gave the name quanta for the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Okay? Now, here, everybody, what is the energy of one quanta? The energy of one quanta is, everyone, as you all can see right here, it is h nu. Now everyone, do we all know that E is equal to hc by lambda, and do we know that h nu, everyone? If you have forgotten, everybody, let me tell you again, what is it? C is equal to nu lambda, wasn't it? So here if we write it, here if we add h, it will be hc is equal to h nu lambda, right? That means we can also write it as hc by lambda is equal to h nu. Makes sense? Makes sense? This is the derivation, everybody. Yes. So for electromagnetic waves, this is energy is equal to hc by lambda, which is equal to h lambda. Now obviously there will be n number of energy packets, right? There will be n number of those packets. So what do? Just multiply it with n. That means that the total energy will become nh nu. Clear hai? See, Planck's quantum theory is super easy. Any doubt, guys, related to Planck's quantum theory? Any doubt, everybody, or did you understand what is Planck's quantum theory? See, with the help of the lace packet, we all understood, isn't it? With the help of the lace packet, we all understood now. Did we? Or did we not? Anybody, any doubt here? Nobody has no doubt? Clear? Absolutely clear? Awesome. 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 Chalo. Now let us understand photoelectric effect, guys. Okay? So for photoelectric effect, it's very important that you understood the Planck's quantum theory, because photoelectric effect says that there is a metal. Imagine there is a metal surface and there is an incident light. The moment there is an incident light, what will happen is the metal definitely has some electrons, right? The metal has some electron. You put the incident light will strike the metal surface. The moment it strikes, some electrons will come out. Some electron will come out. That come out, that word, come out, it can be said in a better English way. Just like how Saranya was correcting me. So let me make my English a little better. And instead of saying that they will come out, we can say that the electrons will be ejected when certain metals were exposed to a beam of light, and this is called as photoelectric effect. This is called as photoelectric effect, everybody. Okay? All right, everyone. So there were certain observations that they made. Okay, there were certain observations that they made related to this photoelectric effect. Everybody, okay, there were certain observations that they made. Yes, what is Kathy asking? Can you once tell the power of 10, 10 to the power minus 34? 10 to the power minus 34. So the observations were that these electrons, they were ejected from the metal surface as soon as the beam of light strikes. That means it is an instantaneous process. They do not waste any time, guys. They do not waste a single second of a moment or whatsoever. The moment incident light strikes, batak. Incident light strikes, batak, they will come out. Okay? They will be ejected. It is an absolutely instantaneous process. There is no wastage of time whatsoever. Now the next question that comes in our mind is, but how many number of electrons will be ejected, ma'am? How do we find it out? Yes, very important question. So let us understand that the number of electrons that is ejected, okay, the number of electrons that is ejected, that is proportional to the intensity or brightness of light. How bright is the light, that will tell you how many number of electron will be ejected. That means if you increase the brightness of the light, if you increase the intensity of the light, number of electrons ejected will also be more. But let me tell you that although the intensity of light will not affect the kinetic energy of the electrons, we will get to know it. We will get to know it because I also have graphs, everybody. I also have graphs. So from there we will understand. But this intensity will not increase the kinetic energy. It will only increase the number of electrons that are ejected. Getting it, everybody? Yes, everyone. And for each metal, each and every metal, if you take sodium, if you take potassium, if you take some other metal, whatever metal that you do, they will have their characteristic minimum frequency. What is this minimum frequency, everybody? See, you have to understand that, everybody. Okay, for example, okay, suppose that Saranya, thank you. Okay, so I'm going to take Saranya and Pranav's example, okay. Suppose Saranya and Pranav, both of them are done with their graduation, after getting through their IIT dream and everything. Now they're sitting in a placement, okay. So when you're sitting in a placement, you will have a minimum number that you want, right? Suppose, let's say, just assuming, okay, assuming that the minimum package that you can expect, the minimum package that you can accept is 15 lakh per annum, okay? Minimum. 15 LPA is the minimum. If it is higher than that, oh, you will definitely, well overjoyed, you will party, you will, sit with your friends and you will give the whole hostel a party, no doubt about it. But lesser than that, you cannot accept, right? Lesser than that, you will feel like, yo, what was the point of them sitting in the IIT, JEE and all? Oh, what was the point that I studied so much and all, I wasted my life and all, everything, and now I'm not getting this much back. You will feel like that, right? Similar to this, these electrons, they can only accept it if the minimum frequency is, overcome. Once they have stepped over the minimum frequency, only then they will get ejected. Otherwise, they will not. Just like Pranav and Saranya, if they are not getting minimum 15, they will not accept it. They will be like, you know what, I don't want it. I will not sit in the placement. Rather, I will go out of the college and then I will get another job. Are you getting it? And that, my dear student, that minimum frequency, that is called as your threshold frequency. What is it called as? It is called as threshold frequency. For some odd reason, my laptop is lagging. Just a minute, guys. My laptop is lagging for some odd reason. I will definitely. Just a second, guys. That for some odd reason, I think it's fine now. Yeah, the lag is over. The lag has gone. Sure, Saranya, I'll let you know. I think it's better now. Yeah, it's better, right? Right, everybody? Hi there. Very welcome to the session, guys. Okay. Now, so what we are saying is that is called as your threshold frequency, isn't it? Yes. Okay. So now what happens is, at a frequency nu which is greater than nu naught. What is nu naught? Nu naught is the threshold frequency that we are talking about, guys. Nu naught is that threshold frequency. Nu naught is that minimum salary that Saranya and Pranav could accept. Okay, all right. Nu naught is the threshold frequency, the minimum salary that they could accept. After that only they will be happy, right? Okay, so at a frequency nu which is greater than nu naught, nu naught is the threshold frequency, the ejected electrons. Acha, now everybody tell me something. Now, guys, listen. Okay, so Pranav and Saranya, now suppose that they were agreeing to take only 15 lakhs, right? They were like, yeah, minimum that much to I want. Now, if by chance, imagine that their marks and all are very good. Now, if they get 20 LPA, what will happen? Overjoyed, whoa, party, they will call the whole lobby like, hey, come, today I will treat you, right? The moment you get your salary, what will you do? You will take your parents like, mama, come, I'll buy you a sari, papa, come, I'll buy you a shirt, right? You will give treat to your whole family, right? After that, there will be some amount that you will also save, right? Some amount that you will also save, isn't it? Yes, for some amount you will keep it like, oh, in the next 5 months I'm going to buy a car. So what will happen to the electron? Now this electron is getting more frequency than it is supposed to be. The moment it has gotten more frequency, it will only use, remember, see, guys, understand this, okay? Now let's suppose that once you have got the job, you only require in a month to survive, just to survive in a big city. Let's say that you only require 40,000. But because you are getting 20 LPA, your salary will be a lot more than 1 lakh, right? Your salary will be definitely more than 1 lakh. Correct. But you require only 40,000. What will you do with the rest? Same. This electron, what will it do? It will keep, मान लो, okay, so मान लेते हैं, for example, the intensity, the frequency was, suppose it was 10. The frequency was 10. But this electron, it only requires 2. What will it do with the extra 8? Dun, 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 dun. Kinetic energy. It will convert that into kinetic energy and it will start running. Dun, 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 dun. It will start running, everybody. So at a frequency nu which is greater than nu naught, the ejected electron will come out with certain kinetic energy, and this kinetic energy of those electrons, it will increase if you increase the frequency of the light used. Am I clear, my dear students? Does this make sense? Does this make sense? Yes. So everybody, this is the whole picture basically. So if you have a metal surface here, this metal surface has an electron. To come out, to get ejected, it needs a function, it needs a work function which is called as phi. Or sometimes we also denote it as W, okay? This is your work function. It will do some work to get ejected. Once it has ejected, then it still has some energy. With that, it will try to run kinetic energy. Dun, 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 dun. It will try to run. Am I clear, everybody? Am I clear, everyone? Yes. So what is happening? The EI, the energy of the incident light, is basically nothing. What is it? That work function that the electron did. Yes, the work function, the work that the electron has done plus the kinetic energy, isn't it? So phi plus kinetic energy is going to be your energy of the incident light. Acha, now tell me that, imagine if your house rent is only 10,000. If your house rent is only 10,000 and the ration that you require is for next 5,000, so that means that your survival, your work function is only 15,000. That is minimum. If you want to survive in your Bangalore is a big city. If you want to survive in Bangalore, suppose by chance, by luck, you are so lucky that you found a house that is only for 10,000. Ration will come for 5,000. So if your work function, your survival is only 15,000, if it is minimum, then your investment will be maximum, no? Right? Your investment will be maximum, no? So what is written here, guys? What is written here, everybody? Check it out. If the work function is minimum, then the kinetic energy will be maximum. Yes? Kinetic energy will be maximum. Anything that is not common sense, guys? Is there anything that is not common sense? Makes sense or nonsense? Does this make sense or nonsense, everybody? See, if phi is going to be less, if phi is minimum, obviously your kinetic energy will be maximum, isn't it? See, this chapter is so easy. Now, Again, from that formula that we had, h nu is equal to h nu naught plus kinetic energy, we know that h nu can be written as hc by lambda. H nu naught can be written as hc divided by lambda naught and kinetic energy. Now, what is kinetic energy? Kinetic energy is half mv square. Kinetic energy is half mv square. So that means that everybody check it out. hc by lambda is equal to hc by lambda naught plus half mv square. Half mv square is nothing but your kinetic energy, everyone. Yes, nothing but your kinetic energy. Getting it, everybody? Is this clear, guys? Is this clear, everyone? Yes? Okay. Alright. Now let us check out some of the graphs, everybody. Okay, let us check out some of the graphs. Okay? Alright? Yes. Hariharan, Pranav, I will come to stopping potential. Don't worry about it. I will come to stopping potential, everybody. Acha, now guys, as I told you, everybody, as I just told you, my dear students, as I just told you, check it out here. So we have the equation that is EI is equal to phi plus kinetic energy. That means we can write this as h nu is equal to h nu naught plus kinetic energy. That means kinetic energy is equal to h nu minus h nu naught. That means that this falls under y is equal to mx minus c, correct? Correct? Y is equal to mx minus c, everybody. Now from this derivation, we can draw the graph for kinetic energy versus nu. Yes, kinetic energy versus nu. Can we not? See, what do you have? You have kinetic energy and you have h nu minus h nu naught, right? So here also kinetic energy versus nu you can draw. So if you take nu in the x-axis and kinetic energy in the y-axis, then what will you get? You know that nu naught is the threshold. Only after the threshold the electrons will get ejected. So till here there is no action. Do you see? Till here there is no action, and then suddenly it goes up. Suddenly it goes up. That means that after the threshold the electrons are ejected. Clear? Hey everybody? Yes. Now, number of ejected electrons, everybody. Nu, frequency and number of ejected electrons. Look at this. There is no change. There is no change. Everyone getting it, everybody? Frequency. This is frequency, nu, and number of ejected electrons. Now if you want to ask me, but ma'am, why ma'am? Why ma'am? Why? What if we draw a graph with kinetic energy and intensity? Then what will happen? What if we draw a graph with kinetic energy and intensity, guys? Tell me. Tell me, everybody. What will happen if I draw a graph with kinetic energy and versus, okay, kinetic energy versus intensity? So if I take here intensity and if I take here kinetic energy, what will the graph look like? The graph, my dear student, will look like this. This will also be a straight line. That means, everybody, that intensity is related to number of ejected electron. Intensity is not related to kinetic energy. I told you this, everybody. Yes, didn't I tell you this? That intensity is related to what? Number of electrons ejected, but not with the kinetic energy. The kinetic energy will not change if you change the intensity. Only the number of electrons that are ejected, that will change, everybody. Clear here, guys? Is this clear, everyone? Yes? Okay. Moving on. There are some more graphs, everybody. There are some more graphs here. Number of ejected electron versus intensity. See, that graph was intensity versus kinetic energy. If I draw number of ejected electron versus intensity, as time passes, if you increase intensity, number of ejected electron will also increase. That is exactly what we are able to see in this graph. Okay, that is exactly what we will be able to see in this graph. Now, my dear student, we come across something that is called a stopping potential. And what is stopping potential? Stopping potential is that minimum potential. What is it? It is the minimum potential which you must apply to stop the photoelectric effect, everybody. And to stop it, you will require kinetic energy is equal to Q multiplied with V naught. That means you can also write it as K is equal to EV naught. Okay, this is an important formula. You can note it down. All right, everybody. Yes, guys. Chalo, moving on. Now let us go to postulates of Bohr's model. Guys, is everything clear here? Till here, everything is clear? This concept in physics, dual nature and particle. Yes, yes, yes. Absolutely. It is there in your physics. Okay. Lalit is asking, is that Einstein photoelectric effect? You tell me, bacha. Lalit, I'm expecting if you are sitting for the 2024 JEE, please know this. Don't ask that basic doubt. I will get a heart attack if you do this. Yes, everything is clear to you all, guys. Everything is clear to you all. See, I have written all of these. I sat and I wrote all of these. Okay, this is my handwriting. If you can see, if you can correlate. Why did I write it? Not because I'm lazy. Only because if I write it during the class, then a lot of time consumption happens. And right now we do not have the time, guys. Time is of essence, right? Time is of essence right now. So that is very important. EV naught basically, bacha, is your kinetic energy. Okay, that is your stopping potential. That is your stopping potential. What is nu naught, bacha? What was nu naught? We have recently seen, no, here. See, H nu is equal to H nu naught plus kinetic energy. So from here we have nu naught, or did I say V naught? Oh no, nu naught only, same, nu naught. Okay, all right, yes. Huh? What are you saying, Saranya? When will you solve questions on each topic? Sachin, your last week, we are done with the 2 weeks challenge, right? 23rd, tomorrow is the last session of your 2 weeks challenge, everybody. 23rd is the last 2 weeks challenge. After that, only thing that we are going to do is questions. Nothing else. Okay, we will only be doing questions. That's it. Okay, all right. Chalo. Now let us move on towards the Bohr model of atom. So Bohr said certain amount of things, right? Yes. Yes, in this chapter there is. Mahesh, what is going on with you, bacha? Mahesh, you have to understand that I'm not just teaching you. I'm teaching a mass. There are certain students in the class, right? What is written in the thumbnail? In the thumbnail it was written, no, concepts, tricks, tips, and problem solving. All of it will happen, na, bacha? All of it will happen. So please hold on. What are you doing? You have been asking the same question since the beginning. I told you that there are problems now. If you are done with the concepts, then what are you doing here? You must actually go and just solve problems, right? This is for those students who wants a quick revision before the exam. So that is why it is important. This is the plan. I can't change the plan midway, bacha. Yes? Otherwise, all the other students who are going to watch this session, they will feel cheated. So please, take it. Please understand. Sure. Okay, now let us understand Bohr's model of atom. Okay, so what did Bohr do? Bohr said that electrons will revolve around the nucleus, but they will revolve not in a haphazard way. They will revolve only in specific permitted circular orbits, and in no other way they will revolve. They will only be specific permitted circular orbit. That's one very important thing, everybody. And when he said that specific permitted orbits, that means that they will be stationary orbits. And while these electrons, they are in the specific orbits, he said that the electrons, they will not be radiating any energy. And these orbits, they will be called as stationary energy levels. That's what he said, right? Then he said that an electron will not be able to move from one energy level to another until and unless they are not absorbing or they are not emitting some required amount of energy. An electron will only be able to move from one energy level, that is one stationary energy level, to another stationary energy level only when they have absorbed or they have emitted required amount of energy. Otherwise that will not happen. Okay? Otherwise that will not happen. Now the angular momentum of an orbit, it is always quantized, everybody, and that you will, my dear student, see here. What do you see? You see mvr is equal to nh divided by 2 pi. So here n can be 1, 2, 3, 4 or anything, and that is why we say that it is quantized. That means it will be discrete, not continuous. If n is equal to 2, that means it will be 2h divided by 2 pi. If n is equal to 3, that means it will be 3h divided by 2 pi. If n is equal to 4, that means it will be 4h divided by 2 pi. So it will always be quantized, everybody. Is this clear, guys? Is this clear, everyone? Yes. Now, Tell me something, everybody, very crystal clearly. You tell me, do you want me to take you through the derivation of radius? Do you want me to take you through the derivation of energy, or just the formula is fine? Whatever you tell me, I will do that. Whatever you tell me, you will do this. Tell me, do you want me to do the derivation or no? Is this fine? Because I know that nobody is going to ask you the derivation. And if you want to know the derivation, guys, if you really want to know the derivation, let me show you. I'm not going to waste time right now. Okay, I'm not going to waste time right now. I'm just going to go through this, everybody. Let me just show you, okay? Let me just quickly show you, everyone. Here, guys, you will find structure of atom, blue color thumbnail. Blue color thumbnail, if you search for, where is it? Actually, you know what? Let us just search here. Structure of atom, VJ English. See, this blue color, guys, this one. Yes, see, it is almost about to be 1 lakh views, everybody. It is almost about to be 1 lakh views, everyone. Yes. So if you just go and look at this, and also this is for just 3 hours, everybody. If you just go to this video, you will find the whole derivation that I have done, everyone. Okay, I've done the whole derivation very well. This is the video that I'm talking about. This is the thumbnail, everybody. So remember it, blue color structure of atom, one short video. You can go and check this out, everyone. So let us now quickly move on, everybody. Okay, so radius of Bohr's orbit. Okay, radius of Bohr's orbit. You know what, let me tell you only how to do this, okay? Force of attraction, everybody, will be what? Force of attraction will be between the nucleus and the electrons, right? Will be between the nucleus and the electron. That can be written as K Q1 multiplied with Q2 divided by R square. Q1 and Q2 will be the charge of the nucleus and the electron, right? Yes, and that will be equal to the centrifugal force. That will be equal to the centrifugal force. So, bacha, understand this. When you are rotating something like this, there is a centripetal force that is acting towards the center. Centripetal force that is acting towards the center. But this exact object is also pulled by somebody outside. Both of the force are balanced. So there is centripetal and there is centrifugal. So the centrifugal force, that also we can write it as KZE multiplied with E divided by R square, right? And from there we will get KZE square divided by R square. Yes, yes, everybody, correct. After that you will just simplify a little bit, okay? You will just simplify it a little bit. KZE square divided by R square is equal to MV square divided by R. If you do katakuti, if you do simplifying, okay, then you will get the radius formula. The radius formula, you will get it as, first you will get it as KZE square divided by MV square. Okay. After that, what you will do is, after that you will do what? Again you will substitute. When you substitute, then you will get such a big formula like this, which is R is equal to N square multiplied with H square divided by 4 pi square M K Z E square. This will be the formula of your radius. Similarly, once you get the R value, then if you substitute it for the velocity value, then you will get the velocity formula to be V is equal to 2 pi K Z E square divided by NH. And if you put the values of the constant, that is K, E and H, then you will get a value like this. Then you will get a formula like this, which is 2.18 multiplied with 10 to the power 6 multiplied with Z divided by N meter per second, everybody. Right, guys? Right, everybody? Yes, okay. And here R will be equal to 0.529, everybody knows, or you can write it as 0.53. Just for approximation, for any formula, you can also write it as 0.53. Otherwise, in actuality, it is 0.52 N multiplied with N square divided by Z angstrom, everyone. Z will be your what? Who can tell me? What is Z? R0 or A0 will become your Bohr radius. Yes, that will be the hydrogen first orbit, everyone. Who can tell me what is Z here? What is Z here? Acha. Similarly, once again, if we try and putting up the values for energy, then we will find the kinetic energy formula, which is kZe square divided by R, and we will get the potential energy formula, which is minus kZe square divided by R, not 2R, R. So that means if you add both of them, very good, Pranav, Sanjay, very good atomic number, well done. So together, if you add them, you will get the total energy, and the total energy will be what, guys? Total energy will be what? See, half minus 1 they are saying. So half minus 1 will be what? Minus half, isn't it? Look at the terms, everybody. Look at the terms. See, kZe square divided by 2R. That means what? Half. Half 1 by 2. Minus kZe square divided by R. That means it is 1. So minus half minus 1 will give you minus half only. No. That is what you are getting. So the total energy becomes minus half, that is minus kZe square divided by R. And here is a relation. Potential energy is equal to potential energy is equal to twice of total energy, and kinetic energy is equal to minus of total energy. Clear hai? And if you put the value of R, then you will get the total energy value to be 2 pi square z square e to the power 4 k square m divided by n square h square. Now this derivation, it would have been fun, but we are a little bit of time constraint, guys. So yes, that's where we're not going. And now here, this is your cheat sheet, everybody. This is your cheat sheet. Whatever formula you need, you require the formula for photon energy, you require the formula for radius, you require the formula for kinetic energy, for total energy, for potential energy, for velocity, whatever formula you need, all of it is right here. For Bohr's model, any formula that you need, this is your cheat sheet. Everybody print it out, write it down. However, stick it in front of your face, stick it in front of your study table, and mark my words, you will be able to know each and every of this formula, guys. Okay? All right. Now, there are some definitions that I have noted it down for you, everybody. Yes, I'll be sending you the PDF. Don't worry. I'll be sending you the PDF in the Telegram channel, so you can just take that and or you can just cut it down, take a snip and print it out. Okay? So here are certain definitions, everybody, that you need to understand. According to that one electron system that Bohr was talking about, that Bohr talked about at that point of time, there were certain definitions that you want to know. What is ground state? Ground state is n is equal to 1. That means the first energy level, that will be your ground state. What is excited state? Excited state can be anything. Excited state can be n is equal to 2. It can be 3, 4, 5, 6 to infinity. It can be anything. Basically, anything that is just above the ground state, that will be your excited state. And to go to the excited state, you always require to absorb some energy. Only then you will be able to go to the excited state. Otherwise, you will not. Not you. I mean, I want to say, I want to say the electron. Sorry, okay? The electron will require to absorb some energy, because you need to understand that the ground state is in a lower energy level. The excited state is in a higher energy level. How do you match it up? You have to accept some electron. You have to accept some energy. Only then you will be able to fit into that excited energy. Yes, yes, absolutely, absolutely. Patil Manoj Kumar, you can definitely check my session for MST CET. Okay? Alright. Now what is ionization energy? Ionization energy, we all know. Ionization energy is basically the energy that is required to remove one electron, isn't it? Yes, to remove one electron. But check it out, everybody, here. Ionization energy is basically from the infinity to minus 1 if you do. Yes, to minus 1 if you do. Infinity, at infinity, let us call it as 0. Yes, let us suppose that the energy will be 0. Then minus 13.6 divided, minus 13.6 multiplied with z square divided by 1 square, because one electron, guys, one electron system. So we're considering it to be hydrogen. So from there, we will get ionization energy is equal to plus 13.6 multiplied with z square. Then we have something called as excitation energy. That means from the ground state to nth level, to any excited level, what is the energy you require? Similarly, once again deriving it, you will get excitation energy is equal to 13.6 multiplied with z square multiplied with 1 minus 1 by n square. Okay? And then we come across something that is binding energy. Binding energy is basically from the nth state. If you want to take it to infinity, then how much energy do you have to go? How much energy do you have to give? So basically it will be E infinity minus energy at nth level. So 0 minus 13.6 multiplied with z square divided by n square. Hence binding energy is equal to ionization energy divided by n square. All right, everybody. Yes, guys. So this is it. Now, obviously, after Bohr's model, we also have certain other models such as Schrodinger's equation. We had, we had Heisenberg's uncertainty principle and several other. Why so? Why is it that we had several other problems? That's because, my dear students, we need to understand that Bohr's model also had certain drawbacks. It also had certain disadvantages. And what were those disadvantages? He could not explain the line spectra of multi-electron system. He could only explain one electron system, hydrogen or hydrogen-like, like He plus or, Li2 plus or some sort of like this. Only one electron system he could explain. He could never explain multi-electron system. He could not explain the distribution of electron in the orbits, which later was given by Bohr-Bury rule, if you remember. Yes, he could not explain how many electrons are there in each orbit. He could never explain that. He could not provide any mathematical support for the quantization of the angular momentum. That NH divided by 2 pi formula, he could not do it any further than this. He could not explain the splitting of spectral lines, that is Zeeman effect, Stark effect, right? He could not explain that. Apart from this, it also was against the de Broglie and Heisenberg's uncertainty principle, my dear students. So now, what is our time? It is our time to understand atomic spectra, everybody. So you know what do you have in atomic spectra? Atomic spectra or the spectrum can be divided into 4 parts and completely based on nature. You can have continuous, you can have discrete, you can have emission, you can have absorption. The emission and the absorption spectra, my dear student, these are complementary to each other. Mane, that means that if emission is the missing lines, then the absorption is the whole spectrum without the missing lines. Getting my point? Suppose, what I'm trying to tell you is that if emission spectra is these lines, okay, just these lines, then what is the absorption spectra? The absorption spectra is basically this. It will be, okay, so suppose these are complementary to each other. Are you getting my point, everybody? So wherever there is supposed to be a line, see, I'm leaving a blank space there. See, I'm leaving a blank space there, everybody. I'm leaving a blank space. Do you see it, everybody? Do you see it? Wherever there was a red line, if the red lines are your emission spectra, then in the absorption spectra, I have left white lines at those positions. Do you see? So that means they are complementary to each other. That means together, if you completely combine them, together they will become the whole spectrum. Okay? Yes, whole spectrum. Okay? Alright. What will you do, Avinash, by knowing that? What will you do? Tell me, what will you do with this? Why am I not teaching you what I'm not teaching you? What will you do with that? Tell me, what will you do with that? So Avinash Bacha, you have to understand that chemistry is very vast. You know, just taking physical and inorganic chapters together for class 11th and 12th, it becomes a huge chunk. And if I have to take care of organic chemistry also, then I will not be able to survive on Saturdays and Sundays. And I do not know if you have noticed, whenever I take a session, I actually do a lot of hard work. You see how I note it down, everything, I write it down, make sure that I give you the handwritten notes and everything. If I have to do that for organic, it becomes very difficult. And this year or the last year was my first year when I was teaching you 11th and 12th standard. It was overwhelming to take physical, inorganic and organic. That's why I chose not to take organic since it is very vast. I thought of asking Durgesh ma'am to take it, and I believe that Durgesh ma'am is also a phenomenal teacher. She's an amazing teacher, everybody. Give her a chance. If you sit in her class, I can guarantee that you will understand organic chemistry also. Okay? Alright, bacha? This is why I'm not teaching. Next year, I will try to do some bits and pieces of organic chemistry. Yes, some bits and pieces. And maybe I will ask some bits and pieces of physical and inorganic for Durgesh ma'am to take. Okay? Alright? Yes, Avinash? Now guys, moving on. Acha, now here is a very important formula, everybody. Can you see it? That the total number of spectral lines. And this question has come in JEE, everybody. This question has come in JEE Mains, everyone, that how to calculate the total number of spectral lines. To calculate the total number of spectral line, you will use this formula, that is delta n multiplied with delta n plus 1 divided by 2. What is delta n, my dear bachus? Delta n is going to be the difference between the n1 and the whatever is the second energy level, that is n. Clear? Okay, now quickly everybody, what is Zeeman effect? Zeeman effect is the splitting of spectral lines in magnetic field. What is Stark effect? Stark effect is splitting of spectral lines in electric field, everybody. So you know what? I have figured out how to remember this. If you forget it by chance, okay. What was this guy's name? Iron Man. Iron Man was what? Iron Man was Mr. Stark, isn't it? Iron Man was Mr. Stark, right, everybody, in Avengers? Do you remember this? I really hope you watch Marvel. Do you watch Marvel movies or not, everyone? Marvel movies, Avengers, you know? Yes? So Iron Man was Stark, and we all know that iron is a great electrical conductor. So that's how I remember it, as Stark, Iron Man, electrical field. Okay? Tony Stark. Yes, Mr. Stark. That's what I said. Okay? So Tony Stark, electrical field, and Z Man. There is Man. So Man. So magnetic. That's how I remember it. Okay? Man, Z, Man, M, magnetic, Stark, Tony Stark, electric field, because Iron Man, and that's how pretty much he died, isn't it? He kind of died like this by getting an electric shock, because he put that and then he was like zooey, gone. Yes, I know, he got Oscar for Oppenheimer. Yes, I know, and so did Cillian Murphy. Anyway, alright guys, so this is done, everybody. Yes, we have understood this. And now, my dear students, by the way, this hydrogen spectrum that you have, this hydrogen spectrum is a stereotypical, what is it? Emission spectrum. It is an emission spectrum. It is complementary of absorption. See, you see lines, isn't it? These lines are your emission spectrum lines, everybody. Yes, what other lines do you have? You have Lyman, Balmer, Paschen, bracket, Fund, Humphrey. Humphrey is in the far infrared region. Okay, bracket is also pretty much in the far infrared region. Okay, Balmer is the only one which is in the visible region, and that was the one that was discovered for the first time. That was the first discovered one. Lyman is in UV radiation. Okay, Paschen and bracket are in infrared, and Fund and Humphrey are in far infrared region. Cool, hey everybody? Yes, guys. Now, if you want to find out the difference between the energy levels, then what do you do? E2 minus E1. That means it is equal to h nu. H nu is equal to hc divided by lambda. Same formula. If you solve it for lambda, then you get this formula, and this formula is, my dear students, called as your Rydberg's formula, everyone. What is this called as? This is called as your Rydberg's formula. I suppose in Rydberg's formula you must not have any problem, everyone, but tell me something. 1 by lambda, can we write it as nu bar? Nu bar is what? Wave number. Wave number, isn't it? Yes, very good, Madhu. So 1 by lambda is equal to nu bar. Nu bar is equal to RH multiplied with Z square multiplied with 1 by N1 square minus 1 by N2 square. Very simple, easy peasy formula. This is basically the formula that we have seen in sort of, we have seen it in thermodynamics. Basically, we have seen it in many different chapters where, you know, this 1 by T1, 1 by T2, 1 by N1, 1 by N2, 1 by P1, 1 by P2, 1 by V1, 1 by V2, isn't it? We have seen this in a lot of places. So I suppose that you will always be able to remember it. Now, question that comes is, what is this RH? RH is your Rydberg's constant, okay? RH is your Rydberg's constant, everybody. If you are given anything, if you are supposed to find it out in per centimeter, then the number that you use is 109678 or 109677 per centimeter. If it is, if you have to write it in the terms of power, then write it as 1.1 into 10 to the power 5 per centimeter. Or if you have to write it in per meter, then you can write it as 1.1 into 10 to the power 7 per meter. Yes. Hey, guys, when did I say that 1 by lambda is a frequency? Guys, Please correct me. Mahesh, you are confused. 1 by lambda is frequency now. Huh? 1 by lambda is going to be wave number. No, bacha. Reciprocal of wavelength. Reciprocal of wavelength is going to be wave number. Frequency is nu. How will frequency and 1 by lambda be the same thing, bacha? Frequency is, okay, please don't get confused. Frequency is this. This is your frequency, nu. Nu is frequency. Lambda is wavelength. Lambda is wavelength. 1 by lambda, reciprocal of wavelength is your wave number, and this 1 by lambda we write it as nu bar. Nu bar. Nu bar is also your wave number. Okay, is the same symbol, but there is a bar symbol on nu. Okay, nu bar. Nu bar is your wave number. Nu is frequency. 1 by lambda is wave number. Please guys, don't make a mistake there. All correct? Yes? All correct? Now is clear? Mahesh? All symbol done? Yes? Got it clear? Got it clear, bacha? Clear? No doubt? No doubt, no? Lambda, wavelength. 1 by lambda, wave number. 1 by lambda can be written as nu bar, wave number, and nu is frequency. Same but different. Yes. same but different. Yes. Okay? Alright. Now here are once again a cheat sheet, everybody. If N1 is equal to this and N2 is equal to this, then the spectral region that you will be getting is ultraviolet and it will be Lyman series. For Balmer series, N1 is equal to 2 and N2 can be 3, 4, 5, 6, whatever, everybody, and that will be in the visible region. For Paschen series, N1 is 3, N2 is going to be 4, 5, 6 and it will be in infrared region. For bracket series, it is 4, 5, 6, 7 is the N2, it will be in infrared. Fund is also in infrared. Humphrey is also in far infrared, by the way, although it is written as infrared, but it is a far infrared region, everybody. See, when you are typing it, everybody, when you are typing it, no, Mahesh, when you are typing it, this symbol, right, this particular symbol is nothing but, actually it is your nu bar, okay? Actually this is nothing but nu bar. So when we write it, we can draw it in italics, right? When we write it, we can draw it in italics, but when you are typing it, it comes as V and you just cut it, okay? Ulta A basically, ulta A, okay? NCRT should be enough for structure of atom, absolutely, yes. Now let us understand the shortest and the longest line of the series. Bacha, which one is going to be the shortest line? Which one is going to be the shortest line? Do you understand from this symbol? From this symbol that from N2 to N1, the first line of the spectral series is always going to be the shortest and the last line is always going to be the longest. So from N2 to N1, it is going to be the shortest, and from infinity to ground state will be your longest line, isn't it? Yes? See, that's what I said. That's what I said, everybody. Shortest line of any series is the lambda of electromagnetic wave, which corresponds to maximum energy difference between energy levels. Maximum energy difference between energy levels, okay? Alright, and the longest line of any series is the lambda of electromagnetic wave, which corresponds to the minimum energy difference between energy levels, everybody. Okay, clear here, guys? Yes. Okay, moving on. Black body radiation we are done with. Photoelectric effect we are done with. Quickly let's move on to de Broglie, shall we? Bohr principle, Pranav, it will come. Bohr principle, Hund's rule, and you know what was it, Pauli's exclusion. We will study all those, don't worry about it. Now guys, de Broglie hypothesis, everybody. So de Broglie, he said that, okay, de Broglie said that the wavelength that is associated with a particle of mass m, which is moving through a velocity v, we can write it as a lambda is equal to h by mv. And h is what? H is equal to Planck's constant. What is the value of Planck's constant? 6.626 into 10 to the power minus 34. What is m? M is in mass in kg, and v is velocity. Now if you ask me, ma'am, how did we arrive to this formula lambda is equal to h by mv? I have done the derivation here. We know that E is equal to mc square. And we also know that E is equal to h nu. That means mc square is equal to hc by lambda, right? Yes, h nu can be written as hc by lambda. That means that lambda is equal to h by mv, and that exactly is what I have written here. Make sense, everybody? Make sense or nonsense, guys? Make sense or nonsense, everybody? Now, the de Broglie hypothesis, there are certain formulas that I have noted it down. See, we all know that mv, this mv, my dear student, is what? It can be written as momentum, isn't it? mv, mass multiplied with velocity, is momentum. Momentum can be denoted with p. So that means lambda is equal to h by p. Will it be correct? It will be correct. Lambda is equal to h by mv. That is our actual formula. Now, if we derive it, everybody, see, we all know that kinetic energy is equal to half mv square. Multiplied left hand side and right hand side both with mm. What will you get, everybody? See, m multiplied with ke and half multiplied with m square v square I'm doing. See, m square v square. Okay? So that means mke is equal to m square v square can be written as c. P is equal to mv. P is equal to mv. So can I write it as p square divided by 2? Can I write it like this, p square divided by 2? I can do this. Now, if I want to find p square it is. So, if I want to just find p, that means it will be root over 2mke. From here, I am writing it down. See, lambda is equal to h by p it was. Instead of p, can I not write it as root over 2mke? I can do this. And I also know that kinetic energy Q multiplied with V or nu, everybody. So that means I can also write it as lambda is equal to H divided by root over 2 mQV, right? Yes. Now for one electron, lambda is equal to 12.24 divided by root over nu in angstrom. These formulas, all of them are very important, everybody. I have written it down. Please keep it with you. Okay? I'll be sending you the notes as soon as the class is over. Please note it down. Okay? So 2 pi r is equal to n lambda and n is equal to number of wave number. That means that you can write it as mvr is equal to nh divided by 2 pi. That means that 2 pi r is equal to nh divided by mv. What is mke? Nothing. Mass multiplied with kinetic energy. What you have done, mke is kinetic energy, m is mass. So you have multiplied mass with kinetic energy. Okay? You have multiplied mass with kinetic energy just to make it p square. Both the sides we have multiplied it with mass. Okay? Okay. See, from here we know that kinetic energy is, but kinetic energy in case of this thing, Q multiplied with V. Kinetic energy can be written as what? Kinetic energy can be written as what, bacha? Quickly tell me. Quickly tell me. You know these formulas, yeah? You have also studied this in physics, isn't it? You have also studied this in physics. Don't you remember electric potential energy V? Oh, that's the V that you guys were asking. Sorry. That's the V that you guys were asking. Chalo, let me write this down only here. Let me write this down. What is key? What is key it seems? Ke. Ke is kinetic energy. What is Q? Q is your charge. Q is your charge. And what is this V? This V is your electric potential energy. Electric potential energy. Okay? And this is the same V that we had written there also. Okay? This is the same V that we had written there also, everybody. Very good, Arvinda. Very good, very good. So here, see, from this formula, from this Ke is equal to QV, what are we doing? Here we have in the fourth formula, what do we have? In the fourth formula, guys, check it out. In the fourth formula, we have 2mke, but instead of ke, I can write it as QV, right? So what have I done? H divided by root over 2mqv. Got it? Got it? Clear now? Yes? Yes? Now is this clear? Great. Chalo. Now, my dear students, we come across another very important and very, very, very interesting thing, that is your Heisenberg's uncertainty principle. What did Heisenberg say? Heisenberg said that we can never ever determine the exact position and the momentum of a fast moving object at the same time, which is actually absolutely true, right? Yes, if something is moving very fast, you will not be able to find the mass into velocity as well as the exact position. The momentum and the position will not be able to we will not be able to calculate it at the same time. Now here delta x is your change in position and delta p is change in momentum. So mathematically delta x multiplied with delta p will be greater than or equal to h divided by 4 pi. Okay. Alright. Now everybody, p, delta p, remember delta p everybody can be written as m into v. Correct everybody? Acha, p is equal to mv. Do you all remember this? We have just calculated this. P is equal to mv everybody, but mass will be constant, right? Mass will not be changing. So delta p is equal to mass multiplied with delta v. Am I clear? That's why I'm writing it as delta x multiplied with m delta v greater than or equal to h divided by 4 pi. Okay. Yes, h divided by 4 pi everybody. This is clear. This was your Heisenberg's uncertainty principle. By the way, this Heisenberg's uncertainty principle, you can also write it for uncertainty in energy. Let me show you. See, for uncertainty in energy, how will you write it? Yes, that will be delta E dot delta T greater than equal to h divided by 4 pi. What is delta T? Delta T will be uncertainty in time. Okay. Alright. Similarly, with time and position also you can do it. Okay. With time and position also you will be able to do it. Am I clear? Am I clear? Got it, guys? Any doubt here? Any doubt here? Chalo, we will come to Schrodinger's wave equation in some time. Okay. First, let us take a look at our electronic configuration. So, Pranav, you were asking for Obo principle. Here we have. Okay. Obo said that, see, it might look a little complicated, but it is actually not so complicated. You have to understand that when we are writing electronic configuration, we will always fill the lower energy level first, everybody. Okay. We will always fill the lower energy level first, and here is a rule, everybody. Okay. Here is a rule. What is the rule, guys? The rule is that if n plus L are different, then whichever has greater n plus L value, okay, whichever has greater n plus L value, that will have greater energy also. But if n plus L are same, then whichever has greater n value bole to, what is n value, guys? N value, my dear student, is your, remember, principal quantum number. Principal quantum number. So yes, whichever has higher principal quantum number, that will have higher energy level, everybody. Clear, hai? And how do you usually fill up your electronic configuration? Your electronic configuration, remind me, is this not how you write it? You write it as 1s, which is lesser than 2s, which is lesser than 2p, which is lesser than your 3s, which is lesser than your 3p, this is lesser than your 4s, this is lesser than your 3d, and so on and so forth, right? That's how you write it. That's how you write it, isn't it? That's how you write your electronic configuration, okay? Moving on everybody, okay? Then we come across something that is called as Hund's rule. Now in Hund's rule, you have to understand that in degenerate orbitals, guys, what is degenerate orbitals? Degenerate orbital means the orbitals that have same energy. For example, px, py, pz, all of them are degenerate p orbitals. Px, py, pz, they have the same energy. Dx, dxy, dxz, dyx, dx square minus y square, dz square, they all have same energy. They are degenerate orbitals. Okay? So Hund's rule said that until and unless, okay, 1 electron is not present in the degenerate orbitals, you will not start pairing them up. So do you understand what we have done? See, here we have initially only what we have done is we have paired them up. That's not correct. That's not correct. Hund said that no. Share it among all the orbitals first. So that is why now we are going to share it among all the orbitals. 1 electron is present in each orbital. Then pair it up. Okay? Then pair it up. Okay? And what did Pauli say? Pauli said that no two electron can have exactly the same 4 quantum number. Pauli said that 2 electrons cannot be spinning the same way. No, the 2 electrons, they will have to be opposite spins like this. Okay, if one rotates like this, the other one will rotate like this. Okay. All right, so that means that we come across what are quantum numbers now, guys. These quantum numbers, they tell you a lot about each and everything related to the electron. Okay, the quantum number, they will tell you the principal quantum number. It tells you about the shell, it tells you about the orbit, it tells you basically about the energy level, and we denote it with the help of n. Then we come across azimuthal quantum number. Azimuthal quantum number is denoted by L, and it denotes the subshell, the suborbit, the sub-energy level. That means that there can be, and it can take values of L0 to N minus 1. Now everybody, if you get the azimuthal value of 1, if you get azimuthal value of 1, that means it will be p orbital. If azimuthal value is 2, then it will be d orbital, right? So like that, okay? Alright, then magnetic quantum number will tell you about orientation. Yes, magnetic quantum number will be telling you about the orientation, and that can take the value of minus L to plus L, everybody. Okay? Alright, and spin quantum number is basically just 2, that is plus half, or minus half, that is your spin quantum number. Okay, guys? Alright, everybody. Yes, is this done? Is this done, everyone? Then we come across the shape of orbital, which I know that s orbital is spherical. You all know p orbitals are dumbbell shaped, d orbitals are double dumbbell lobes, isn't it? Yes, everybody. And then you have the f orbitals, which are even more complex. Now, my dear students, we come across the Schrodinger wave equation. In the Schrodinger wave equation, what do you get to notice? You get to notice that it describes the 3D motion of electron around the nucleus. So you know that the atom is not 2D, right? The atom is actually 3D. So in the 3 dimension, how is it moving? How is the electron moving in the 3D motion? That is what it tells you. Okay? That is what it tells you. So here, if you look at this equation, this complex equation, that is dou square psi divided by dou x square plus dou square psi divided by dou y square plus dou square psi divided by dou z square plus 8 pi square m divided by h square multiplied with e minus v multiplied with psi is equal to 0. Here, what is what, everybody? Psi is your wave function. Okay, psi is your wave function. Writing it down, everybody. Check it out here. Psi is your wave function. X, Y, Z are your Cartesian coordinates. Yes, these are your Cartesian coordinates. You know, everybody, yes. You know what you have, right? You have the coordinates, isn't it? X axis, y axis, and z axis. So the coordinates that you have, that will be your Cartesian coordinates here, x, y, z. E is going to be equal to your total energy. Mass is going to be mass of electron. V here that you see, this V is your potential energy, right? And H obviously is your Planck's constant, my dear students. Yes. Now this x, y, z, everybody, okay, this x, y, z, if we solve this, so this is x, y, z is in Cartesian coordinates, isn't it? This x, y, z is in your Cartesian coordinates. I'm sure that you have learned it in your mathematics, isn't it? In your mathematics, you have it. You have Cartesian, and then if you solve this equation in polar coordinate, nobody needs to solve it, guys. You don't have to solve it right now. You might have to solve it only when you go to your masters or in your graduation. That too, by the last year of your graduation, you will probably be solving Schrodinger. Maybe even not then. Okay? Maybe even not then. So if you take this Cartesian coordinates and then if you solve it in polar coordinates, guys, are you understanding what am I saying? For example, chalo, let me add a page here. Okay? Let me add a page here and let me try to explain this here. For example, what I'm trying to say here is, suppose you have your y, x and z, right? These are your coordinates. So this is your x, this is your y, this is your z, correct? Yes. So this x, y and z, if you solve this in the polar coordinates, which are your polar coordinates, then it will become r, theta and phi. What are these? These are your polar coordinates. These are your polar coordinates. So basically, right here, if you solve it, this point will no longer will have x, y and z, but it will have r, theta and phi coordinates. Okay, all right. So this will be your polar coordinates, everybody. When you solve it, you get different values of psi. Okay, what do you get? You get different values of psi. And those different values of psi will be psi 1, psi 2, psi 3, whatever. Now, some of those psi values, they are meaningful. That means they tell us something about it. They tell us something about the wave. Those meaningful values, my dear student, they are called as eigen values. Have you learnt about this? Eigen values in your mathematics? Have you? Have you? You will come across something called as eigen values. Okay? These meaningful values that you get, they are eigen values. And this psi in terms of r, okay, with respect to r, if you find, you will be getting two parts. There will be two parts you get after the solution, guys. Nobody is going to teach you how to solve this. You do not need to know how to solve Schrodinger equation right now. Please understand this, okay? So here, psi r, you will get two parts. One will be your radial part. One will be your radial part, okay? One will be your radial part, where you will be getting that r of r, it will be coming, or psi of r, it will be, okay? And the other part will be your angular part. It will also show you some angle, okay? Angle. It will signify some angle, my dear student. By the way, tell me something. Didn't you realize that there will be some angle when you saw theta? The moment you saw theta, I'm sure that your mind would have been like, theta means sine theta, cos theta, tan theta. It's some angle, right? And there is r. There is r, so that is going to be your radial part. That means that now if we solve this Schrodinger equation in the polar coordinates, and if we solve it for the s orbital, we will see that the radial part will be there, but the angular part will not to be seen. The angular part will not be seen. That shows that the s orbital is spherical in shape. There is no angle, okay? And by the way, one thing that this particular equation could not tell us is, remember the quantum numbers? Yes, the spin quantum number could not be determined by Schrodinger wave equation. But it can show you the principal quantum number, it can tell you the azimuthal quantum number, and it can tell you about the magnetic quantum number, but it cannot tell you about the spin quantum number. Now, by the way, one more thing that you need to understand is that the psi, okay, just if you take the psi, it has no physical significance. It has no physical significance. That means it does not really tell us about anything, okay? It does not tell us about anything. It has no physical significance. But the moment you square it, the moment you take psi square, it has physical significance. It has physical significance. And do you know what this psi square tells us about? This psi square, my dear students, tells us about the probability of finding an electron. If the psi square is maximum, that means that right at that point, there is an orbit. There is an atomic orbital. That means that you have found the electron. The electron is orbiting at that point where you are finding the maximum value. The moment you find a minimum value, that means almost closer to zero, that means that it will be a node. Now you will ask me, ma'am, what is a node? Okay. S orbital does not have a node, but do you know p orbital? See, this is your p orbital. This particular position, this particular, where these lobes are interconnecting, that is called as a node. That is the place where you are not gonna find an electron. The electrons will not exist at a node. The probability of finding an electron at the node is 0. Getting it, everybody? Yes, guys. Is this clear, everybody? Now tell me, is there anybody any doubt? That's all you need to know. Nothing extra you need to know from Schrodinger's equation. You don't have to solve it. Nobody is going to ask you that. But you must know what is the significance. Psi square tells you the probability of finding an electron, everybody. Yes, if it is 0, if it is minimum, that means that it is a node. You have found a node. Node is a place where you will not find an electron. Node is a place where, you know, the orbitals are interconnecting. Yes, this where the lobes are interconnecting, that will be your that will be your node. And wherever you see that, oh, psi square value is maximum, that means right at that position you do have an electron which is revolving around the nucleus. Clear? Yes. Now, related to Schrodinger's equation, everybody, you can draw some graphs here. Yes. Again, this psi of r and r, if you take, you will get a, for 1s orbital, this is what you will find. Yes, for 2s orbital, you will find that there is, for 2s orbital, you will see that it is, for 2s orbital, you will see that there is, it is just going upwards a little bit. Just check it out. Just check out the diagram. Now, psi of r you have drawn. What if I ask you that draw for psi square? The moment I ask you to draw it for psi square, then for 1s orbital, you will see that it will completely lie on the x-axis. But if it is 2s, that means it will touch and go. You know what? Let me draw it and show you. I think that will be better, everybody. That will be better. This way you will not be able to remember it, but if I draw it and show you, then I think you will be able to remember it. Chalo, let us draw it for each one of them, okay? Let us draw it for, Arey Baba, what elaborate quantum numbers? What more elaboration do you need, Mahesh? Huh? Principal quantum number tells you about the energy shell, bacha. The 4s, 3d, those 3d, that 3 is the principal quantum number. 4s, 4 is the principal quantum number. Okay? Azimuthal quantum number, that 3d, 4s, the d, sp, df, azimuthal quantum number tells you about those sp, df. Magnetic quantum number tells you about orientation. Spin quantum number tells you about the spin of the electron. There is nothing more to elaborate. What more do you want me to elaborate? And please understand, this session is for quick revision, bacha. This is not for elaboration. No clear idea. What more do you want? Tell me. Electronic configuration, you know how to write. 1s, 2s, 2p, 3s, 3p, 3, 6. Yes, exactly. That 1, 2, 3, 4, that is your principal quantum number. SPDF, azimuthal quantum number. Magnetic quantum number tells you about the orientation of the magnet. Okay. And the last one, spin quantum number, will tell you how the electron is spinning. That's it. Nothing else. Okay, chalo guys, let us draw the graphs. Okay. Okay. Now, first of all, let us draw it for s orbital. Okay. For s orbital. So everybody, check it out here. Drawing the graph here. Drawing the graph. This is your r. And this time we are taking s. So our graph for 1s orbital, okay, for 1s orbital, our graph is going to look a little like this. Okay. This will be for 1s. Okay. This will be for 1s. Now, my dear student, tell me, radial node, how do you calculate the formula? What is the formula? N minus L minus 1, isn't it? N minus L minus 1. Correct? Correct, everybody. N minus L minus 1. Yes? Yes? So that means that if I check, okay, alright, not understanding. See, radial node. Let us calculate it, okay? Radial node will be N minus L minus 1. Now suppose I ask you, let us draw it for 2s orbital. What will you do? 2, yes, N is 2. For L value for s orbital, guys, s will be 0. L is azimuthal quantum number. Azimuthal quantum number for s orbital will be 0. Minus 1 is equal to 1. And this shows that if I draw it for 2s orbital, everybody, like this, then there will be one cut that the graph will do, okay? The graph will basically go like this, okay? So there will be one cut right here, okay? Alright, everybody, getting it? Now, if I tell you that draw it for 3s orbital, see, how will you draw it? For 3s orbital, guys, for 3s orbital, once again, what will happen to the radial node, guys? Radial node this time will be 3 minus 0 minus 1 is equal to 2, am I right? That means there will be two cuts. So everybody, check it out, drawing the graph, everyone, see. What am I taking here? This will be r, this will be psi, isn't it? Now, if I want to draw the graph, two cuts. So it will be one like this and like this. See, two cuts. Check it out, everybody. Yes. Yes. Do you understand this? Great. Now, let us start drawing it for psi square versus r. Okay? Psi square versus r. Okay? Now, here what you are going to do is, one trick is there, that whatever is in the negative part, make it positive. whatever is in the negative part, make it positive. See, for example, this 2s, was going, this is the part that is in the negative part, right? You are just going to make it positive. Just make it positive, everybody. So check it out. For 2s orbital, for 1s orbital is there in the graph, so you can check it out, okay? For 2s orbital, if I draw it, see, how am I going to draw it? This is my r, this is my psi square, okay? So what am I going to do, everybody? What am I going to do? I am going to draw it like this. There is a cut mark here, right? After cutting it, it will go up and it will go like this. This will be for 2s, okay? Alright, now for 3s, everybody, for 3s, see. For 3s, everyone, for 3s, everybody, what am I going to do? Let's draw the graph. This is r, this is psi square. And now, what am I going to do? I'm going to cut it like this, okay? And then this will go here. And then what will happen? Then it will go like this. See? Only thing that I've done is this part made it into positive, okay? Alright. Yes, everybody. Similarly, you can draw the graph for 4s, 3d, 4f, 4d, 5f. You can draw it for all, okay? You can draw it for all, everybody. And with this note, I am guessing that we have come to the end of it, everyone. We are almost done, yes? Ha! We are done, guys. Chalo. Now let us solve some questions, everybody. Yes? Everything is clear, I hope? Chalo. Let us solve some questions, shall we? Are you all with me? Draw with Anika. I'm from grade 8. Where are you? Oh, bacha, I left Young Wonders a long back. This is all more than 1 year that I am here now. Okay? More than 1 year. Don't worry about it. You quickly, get done with your class 8, class 9, class 10, and I'll be waiting for you in class 11. Okay? I'll be waiting for you in class 11. So you quickly come and I'll be here. Chalo. All right, guys. The question is, if lambda naught and lambda be the threshold wavelength and wavelength of incident light, the velocity of photoelectron ejected from the metal surfaces. Chalo, let us solve it. For this, we will have to do derivation, guys. For this, we will have to do a little bit of derivation. Now, we know that. What do we know? We know that h nu is equal to h nu naught plus kinetic energy. Am I right? Yes. That means that kinetic energy can be written as half mv square. Correct? Half mv square can be written as h nu minus h nu naught. Am I right? That means that this can be written as hc divided by lambda minus hc divided by lambda naught. Am I right, everybody? Yes. Sorry. Now I can also write it as v square. Sorry, guys. Sorry. Okay, check it out. So your v square is going to be equal to what? It will be 2hc. We can take it as common, right? 2hc and m, let's divide it here. So 2hc divided by m, and here we can write it as 1 by lambda minus 1 by lambda naught. Correct? That means that v is equal to, what will be v? V is equal to 2hc divided by m, 1 by lambda minus 1 by lambda naught, covering the bracket 1 by half. Or instead of writing half here, I can take out the square bracket and directly I can write it like this, isn't it? Yes. Or what I can do, everybody, is, since it is 1 by lambda minus lambda naught, see what I can do it here. I can write it like this, isn't it? It will be lambda naught minus lambda divided by lambda multiplied with lambda naught. Can I write it like this, everybody? Yes? Now tell me, is this correct? So which is the option? Which is the correct option, guys? The correct option is option number D. See, derived? Yes? Easy peasy biryani tasty? Is this EPBT? Yeah, exactly. We just did that. We just did that. Hi Ramesh, very good evening, bacha. Chalo. Next question, can I give it to you as homework? Next question, I think you can do it. Which one of the following about an electron occupying the 1s orbital in a hydrogen atom is incorrect? Okay, the total energy of the electron is maximum when it is at a distance a0 from the nucleus. Chalo, let me tell you guys. Yes, is the total energy maximum? Is the total energy maximum, everybody? Huh? A0, guys. See what is it saying? The total energy of the electron is maximum when when it is at a distance a0 from the nucleus. A0 is the radius of the Bohr atom, isn't it? A0 is the radius of the Bohr atom. That means right at the radius it is saying that the electron will have the maximum energy. No, it will actually have minimum energy, guys. It will have minimum energy, everyone. Don't you remember? Yes, we have done this. Very good. Because at A0, the electron is at a stable position, right? At A0, it will be at stable position. That's why it is able to revolve. The moment it comes closer to the nucleus, it is not stable. The moment it comes closer, that means that's where it will have higher energy. At A0, it is stable. If it is stable, that means energy is less. If it is stable, then energy is less. So this right here is the actually wrong answer. I thought of giving it to you as homework, but no worries, no worries. Now I want you to do one thing, everybody. Those of you who are studying, okay? Those of you who are studying, everybody, from me, from here, can I tell you one thing? All the other ones, okay, all the other B, C, D options, everyone, can you find out the reason why they are correct, guys? Will you be able to find out the reason why they are correct? Because I have just taught you this concept. So once I give you the, once I give you the PDF, please find it out and write down, because you never know what NTA can do is they can use one of this, change it little bit, and they can give it to you as a mistake. That can be your incorrect option. So please find out the reason. Promise me you will do this. All the students who are here, all the students who are here, will you be able to find it out? Please, will you do this for me? Do this for me, okay? Chalo, next question, everybody. The quantum number of 4 electrons are given below, okay? Okay. The correct order of their increasing energies will be. Chalo, let us solve it. Chalo. See, the first one is n is equal to 4, L is equal to 2, ml is equal to -2, ms is equal to minus half. ms is equal to minus half. ms too, we do not need to consider it at all, okay? N is equal to 4, L is equal to 2. So that means that N plus L is equal to how much? N plus L is equal to 4 plus 2, that means 6, right? That means that also N is equal to 4 or L is equal to 2. The moment you see this, you have to understand that it is going to be 4D. It is going to be 4D. Moving. It is going to be 4D. है ना? ठीक है. N is equal to 3. L is equal to 2. 3 and 2. 3 and 2, everybody. 3 and 2, that means this is going to be 3D. Right? Next, 4 and 1. 4 and 1 means 4P. Yes? 3 and 1 means what? 3 and 1 means 3P. So which one will have the lowest energy, guys? It will obviously be 3P. 3P will have the lowest energy. After that, you will have 3D. After that, you will have 4P, and finally you will have 4D, everybody. So what is going to be the answer? 3P is 4, 3P is 4, 3D is 2, 4P is your 3, and 4D is 1. So 4231, 4231 is option number D, guys. Option number D, everybody. Yes. Done? Done, everybody? See? Easy peasy biryani tasty. So from this chapter, once again, my dear student, I believe that whatever you get, you will be able to do it. You'll be able to do it. It's not a very difficult chapter. I think you'll be able to do it, okay? Just go through the derivations one more time, because if at all you need to derive, then you will be in a fix, right? Yeah, just n plus L values, exactly. See, such an easy question. But just by looking at the, length of the question, you would have thought, oh my God, dead. You would have thought like that, hai na? Chalo guys, next question. The de Broglie wavelength of a neutron when its kinetic energy is K, capital K, is lambda. What will be its wavelength when its kinetic energy is 4K? Okay. So what is it saying? It's saying that kinetic energy of what? Neutron. Kinetic energy of neutron, everybody, is written as half mv square. Kinetic energy means half mv square. And this is given to you as capital K. Correct? That means that V is equal to 2 capital K divided by m root over. Can I write it like this? Yes. Okay. Now the de Broglie wavelength factor, let's bring in. The de Broglie wavelength is equal to what? H divided by P, isn't it? Yes, H divided by P. H divided by m multiplied with V. So we can write this as H divided by mv. That means that this can be written as, remember those formulas that I gave you guys? Those formulas that I gave you, see from here only, H divided by, can I write it as 2m capital K? Can I write it as 2m capital K? Because V is what? V is equal to 2K divided by m. But here there is an m. So m and m will get cancelled. M and m will get cancelled. So it will be root over 2mk. This can be written as proportional to 1 by root over k. Just for the sake of it, to make it convenient for us, can I write it like this? That means when the kinetic energy will become 4k, then what will be de Broglie wavelength? What will be de Broglie wavelength, bacha? Now find it out. Now tell me. Now you tell me, guys. Now you tell me. Now when the kinetic energy, I have done majority of the hard work. I have done the hard work. Now just look at this relation and tell me that if now the kinetic energy becomes 4k, then what is going to be the wavelength? Very good Pranav, very good. Yes, it is going to be lambda divided by 2. Well done. Yes, Pranav has said that. Mahesh, were you able to solve it? Mahesh, were you able to solve it? Option B, yes. Mahesh, I hope that you were also able to solve it. Chalo, next question, everybody. Next question is, if uncertainty in velocity is 6.62 into 10 to the power minus 2 meter per second for a particle of mass of 0.05 divided by pi gram, its uncertainty in position will be what? Okay, so these are the options. Chalo, let us solve it. So we know Heisenberg's uncertainty principle, that is delta x dot delta p, isn't it? So delta p, instead of delta pc, right here we are given m dot delta v, guys. Remember, delta p can be written as m multiplied with delta v. So that means that delta x multiplied with velocity is 6.62 into 10 to the power minus 12. Right? This will be greater than equal to, remember Planck's constant, so it will be 6.62 into 10 to the power minus 34, right? Divided by, what do we have? We have 4 pi, isn't it? 4 pi. So it will be 4 multiplied with pi multiplied with, see, mass is given, 4 pi m. Mass is given. So that means this will be 0.05 into 10 to the power minus 3, because this is in gram. Yes, we don't want it in gram. Divided by pi. Can I do this? Yes. If I do this, now what will happen? Simplify. 10 to the power minus 12, 10 to the power minus 34. That means that delta x is greater than equal to, everybody, 34 and 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 19. So 10 to the power minus 19. And here you have 4 into pi into 0.05. So pi and pi will get cancelled. So 4 into 0.05. 4 into 0.05 will be how much, guys? Gram. GM is gram. Mass, no, gram. 4 into 0.05 will be 0.2, isn't it? So that means that delta x is greater than equal to 0.2. 1 divided by 0.2. 1 divided by 0.2. So it can be written as 1 divided by 0.2 can be written as how much? No, it won't be D. 1 second. Here, see, my maths got stuck. My maths got stuck here. Now I'm stuck. Wow. 1 divided by 0.2. 5. 1 divided by 0.2 can be written as 5, isn't it? 5, 5, 5 guys, 5, 5. So if it is 5, that means I can write it as 0.5 into 10 to the power minus 18. Instead of writing minus 19, I can write it as minus 18. So yes, option A will be correct answer. Option A will be your correct answer. Very good guys, very good, very good, very good. Well done my bachos, well done everybody. Okay, chalo guys, next question. Yes, okay, this I'm not doing it. We have done enough number of questions like this in DNF block. I'm not doing this, everybody. You can take this as homework. Okay, you can take this as homework. Total nodes in 3D orbitals. How do you calculate total nodes in 3D orbital? What do? You do n minus 1 to calculate nodes. That means 3 minus 1 is equal to 2. That's it. These type of questions also come in JEE. Can you believe it? These type of questions come in JEE. The correct answer is 2. And with this note, we are done with the session, guys. That's it for today. We are done with the session. After this, Durgesh Nandini ma'am is going to take a session, if I'm not wrong. I think that I have seen it, everybody. Right? So let us just let's just click on this. See? Yes. See, I am live here. Guys, have you liked the session? Liking the session. Thank you so much. Thank you so much. So after this session, everybody, after this session, I think Durgesh ma'am is taking a session. Yes, amines. She's doing amines, and yes, at 7 o'clock. So you have another 50 minutes, everybody. Yes, she has another 50 minutes, everyone. In 15 minutes, she'll be taking a session. So you guys go take a break, but be ready. And please do not forget to attend the sessions. She will be taking it. And by the way, guys, everybody, whoever wants to visit Pune or Hyderabad, where Shreyas sir is going to be there, you guys can go and meet Shreyas sir, everybody. Yes, Shreyas sir is going to be there in the centers, everyone. Please go register for it, and please go and see him. I'm guessing that sir will be over the joy. Please go there. Talk to us. We like it, we also like it. Just like how you all, Saranya told me or Pranav told me that, ma'am, we would like to meet you. We also want to meet you. So if we are coming to your city, please do come and meet us. It will be one of it will be one of our dream come true as well, because while we are teaching you here, sometimes we are not able to meet you, and and that's kind of sad that this is probably one con of the online teaching. So if you are getting a chance, please do come and see us. I will also come, Pradeepa, but you have to keep writing it down that you want to meet Nabamita Ma'am, you want to meet me. Okay, only then Vedantu will send me, otherwise they'll not send me. Just kidding, everybody. So with this note, guys, I'll be ending the session today. Thank you so much. Thank you so much. Thank you so much, Shri. Thank you so much. I will see you all very soon. Lots of love. Tomorrow I'll be taking redox reaction, and that will be your end of your 2 weeks challenge. I hope that you have understood each and every lesson, each and every chapter that we have taken you through, everybody. Thank you so much. Please keep supporting us. Please keep, checking out our channel. Stay tuned to our channel, and do not forget to like, share and subscribe it. Do not forget to share it with your friends. I'll see you very soon, and lots of love. Tomorrow at 11 o'clock, I'm going to see you guys. Okay. Bye. See ya. All the best.